Section 6.5 talks about two different types of special cases for factoring, and I thought I would separate them into different videos. The first one is called the difference of two squares, and I think the best way to demonstrate this is just to go ahead and show you again the reverse. So let's say we have a plus b times a minus b. So let's go ahead and multiply these two binomials together. So first of all, we would multiply a times a, so I'll give you a squared. Then a times negative b, so I'll give you minus ab. And then plus b times a, so it'll give us plus ab. So it's b times a, but remember that multiplication is commutative. You can write it as ab or ba. And then minus b squared, because you have this plus b times minus b gives you minus b squared. Okay, let's clear that off. And notice something that's pretty important here. We have a plus ab, a plus ab here, and a minus ab here, so they cancel each other out. So this can be simplified further to a squared minus b squared. Now let's write this as a rule, but in the opposite direction. See, what this means is that if a, let's put it over here. If a equals, since we're already using a, let's not use a. If x equals y and y equals z, this is a pretty important. This should be pretty clear, but this is a pretty important algebraic concept to understand. If this is true, then this is true. If x equals y and y equals z, then x equals z. And if x equals z, then z equals x. And that's exactly what we have here. So what we have that a squared minus b squared equals a plus b times a minus b. So I just put this on the left side. So if a squared minus b squared equals a plus b times a minus b, then we can use this to use different to take, if we have two square numbers that are being subtracted, one's being subtracted from the other, we can rewrite it in this form. So let's say, for example, we have x squared minus 4. This is a pretty basic example. So this is a square number, it's x squared. This is a square number, it's 2 squared. So that means we can write this in this form. Instead of x squared minus 4 squared, so here a is going to be x and b is going to equal 2. So we can rewrite this then as I'm going to do it over here. So we can take this and rewrite it as x plus 2, because that's a plus b times x minus 2, because that's a minus b. So let's go ahead and type that out. So we have x squared minus 4 equals x plus 2 times x minus 2. Okay. So this is an example of how you can use the difference of two squares property. Let's do a couple more examples. So let's say we have 25x squared minus 16y squared. This one looks more difficult at first, but it's exactly the same thing as up here. Let's put a little more space there. Okay, so just so we can keep the examples separate. So this x squared, this 25x squared minus 16y squared, well here 25x squared is the same thing as 5x quantity squared. Because you're squaring 5x, you get 25x squared. And this 16y squared is the same thing as 4y squared. This is pretty important to understand, that this is going to be 5x quantity squared, and this will be 4y quantity squared. This is a pretty important concept to understand. So now, since this is 25, since we know what a is going to be 5x, b is going to be 4y, so we can rewrite this as 5x plus 4y times 5x minus 4y. And we can double check this. I didn't double check this one up here, but I'll go ahead and double check this one. And we could double check it just the same way we have before. We just go ahead and multiply them out. So we'll have 5x times 5x will give us 25x squared. And then 5x times minus 4x will give us minus 20xy. 4y times 5x will give us plus 20xy. And then plus 4y times minus 4y will give us minus 16y squared. So these two terms cancel out, and we get 20x squared minus 16y squared, which is what we were given originally. So that means that this answer is probably going to be right. So I'll go ahead and write that down at the bottom here. So we have 25x squared minus 16y squared equals 5x plus y times 5x minus y. Okay, so let's go ahead and clear all that off. This is a pretty common... Ooh, nope, I copied that down wrong. 4y. Okay, it's pretty common to mix this up. A pretty common mistake that I see is people will multiply out squares this way. So like they'll say x plus 5 squared, or sorry, not 5, not plus. They will sometimes do plus, but sometimes that means people will multiply this out as x squared minus 25. That is absolutely not right, though, because it has to be x plus 5 times x minus 5 for that to work. So it's pretty important to understand exactly how this is working out the way it is. Let's do one more example. And I'm going to do this one without a safety net. I'm going to do it without this reference up here. So we have 64c squared minus 1. So this is our example. 64c squared minus 1. 64c squared is going to be the same thing as 8c quantity squared. And 1 is 1 squared. So we're subtracting a square from another square. So we can say that this is equal to 8c plus 1 times 8c minus 1. And we can double check that. I'll go ahead and do that. So if we want to double check this, we'll say 8c times 8c will give us 64c. 8c times negative 1 will give us minus 8c. 1 times 8c will give us plus 8c. And 1 times negative 1 will give us minus 1. Minus 8c and plus 8c cancel out, so we'll get 64. I forgot to put the c squared here. C squared. So 8c times 8c gives us 64c squared. So 64c squared minus 1. That's the original problem we were given. So that means we probably got it right. So this is going to be our final answer. So I'll go ahead and write that down more formally. So we have 64c squared minus 1 equals 8c plus 1 times 8c minus 1. And let's clear that off. So 64c squared minus 1 equals 8c plus 1 times 8c minus 1. Alright, that concludes the difference of two squares. I will see you in the next video.